Today I discuss about minors and cofactors of a determinant. Minors and cofactors. Of a determinant. Let delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 be a determinant of third order. Now you write analytically for the elements of first row. You first learn analytically. You write cofactor of A11 and we denote this by A11. Okay, this will be equal to, you first write minus 1 whole to the power, that number of row this element belongs to, that is 1, plus the number of column also it belongs to 1. You omit this row and this column mentally. So you see A22, A23, A22, A33 minus A23, A32. So, as a whole, this is the cofactor of the element A11. If you omit the sign, then you will get this. As a whole, this is the cofactor of A11. But if you omit the sign to get this, and this will be your minus 1 whole to the power 1 plus 1 M11. M11 is the minor of the element A11. Clear? Now the elements of A12. So it will be A12. It will also be A12 minus 1 whole to the power number of row this element belongs to, that is 1. Then number of column this element belongs to is 2. So you write 2 here. Omit this row and this column. So A21, A33 minus A23, A31. So this is the cofactor of the element A12, and this is the minor this is cofactor including this sign, but the minor is this. This is M12. This is minor of this element. Now this is very simple and interesting also. A13, it will also be A13. This is also plus 3 because A13 belongs to first row and third column. Omit this to get A21, A32 minus A22, A31, and this will be your minus 1 whole to the power A13 M13. So this is minor, and as a whole this is cofactor. So minor is nothing but omitting of sign in cofactor. The remaining factor is the minor. Clear? So that was for the elements of first row. Now if you consider second row, cofactor of A21, cofactor of A21, this will be 21. Minus 1 whole to the power, number of row it belongs to A2 plus 1. It belongs to second row and first column. Omit this, omit this. A12, A33 minus A13, A31. So it will be your minus 1 whole to the power 2 plus 1 M21. So this is the minor of this element where the sign will be ignored. You write for the element A22, it will be 2 plus 2. Omit this, omit this. A11, A33 minus, omit this, omit this. A11, A33, A13, A31. And this will be your minus 1 whole to the power 2 plus 2 M22. Clear? Now for the element A23, this will be 3, this will be 3, and number of row it belongs to is 2 and number of column it belongs to is 3. So you omit this row and this column to get A11, A32 minus A11, A32 minus A12, A12, A31. And in a similar fashion, only this will be the minor of this element. Okay. In a similar fashion. It is in a similar fashion. So, second row has already been completed. Now, we consider for the elements of third row. Third row. Third row, first element A 3 1. So you write A 3 1. This is just notation, not more than or not different from any other. Number of row it belongs to 3 plus number of column it belongs to also 1. Omit this row and this column to get A12, A23 minus A13, A22. So this will be the minor. Again I say this will be the minor only of A31, of the element A31. Now I hope you are easily understanding my discussion. A32, A32, A3 plus 2, you omit third row and second column. A11, A33, no, third row and second column, third row and second column, A11, A23 minus A13, A21. This and this, those were omitted. So A11, A23 minus A13, A21. Clearly this is the minor of A32. A33, A33, you write here 3, omit this, rewrite third row, third column, third row, third column, A11, A22 minus A12, A21. So we have calculated all the cofactors of the 9 elements of this determinant. For this reason, I have told you earlier in my early videos related with determinants, that either we will expand a determinant by considering the elements of first row or first column. If you consider, for this reason, if you consider the elements of second row or elements of second column to expand a determinant, then all the signs will be opposite to that as was considering elements of first row or considering elements of first column. Okay. Now I take a simple example. Simple example. Find the cofactors of, say, 2, 0, -3, 5, 1, 2, or say it's 7, 0, 3, -3, say -5. Now it is very simple. For the elements, for the sake of simplicity, in the primary level you always try to write in this format, and then I teach you what will be the shortest process to obtain the cofactor of any element of a determinant. For the elements of first row cofactor of 2 equal to, you write -1 or to the power number of row it belongs to plus number of column it belongs to. Omit them. So -5 -21 equal to -1 whole to the power 2 into -26. So minor of 2 that is for the elements of, there may be more 2's in any other rows or columns. Minor of 2 of first element of first row and first column equal to -26. Clear? Cofactor of 0. You mind that this obviously not equal to 0, but what is the factor when we expand this determinant according to rule? What is the factor of 0? That is the cofactor, and this is equal to -1 whole to the power number of row, number of column it belongs to, omit them, number of row, number of column it belongs to. So -25 minus 0 equal to -1 whole to the power 1 plus 2 into -25. Minor of 0 of the element belongs to first row and second column, minor of 0 equal to 25 minus 25, but it is minus 1 whole to the power 3, that is minus, and minus minus a plus, and you see the cofactor of 0 is 25, but minor of 0 is minus 25. This is the minor, ignoring the sign in front of it as a multiplier. Cofactor of minus 3 equal to minus 1 whole to the power number of row it belongs to plus number of column. Omit it, 15 minus 0 equal to minus 1 whole to the power 1 plus 3 into 15. So minor of minus 3 is 15, but cofactor of minus 3 is whole thing. Okay, so this completes the minors and cofactors for the elements of first row of this determinant. Now we consider for the elements of second row. Second row, cofactor of 5 equal to minus 1 whole to the power number of row it belongs to 2, number of column it belongs to 1. Omit them. Number of row, number of column. So this is 0 minus 1 plus 9 equal to minus 1 whole to the power means minus 9. So this is the cofactor of 5, but minor of 5 equal to 9. Clear? Cofactor of 1 minus 1, the 1 belongs to we are considering the all elements for second row, so row number 2 and column number 2. Omit them. Row number 2, column number 2. Minus 10 plus 0. So 0 will be out, and this minor of 1 equal to minus 10. Here you see minus 1 whole to the power 4, this is plus and this is minus 10. All these two values are same, but the technique, as I discussed earlier, cofactor of 7, number of row it belongs to 2, number of column it belongs to 3. Omit them. 6 minus 0. So this is minus 1 whole to the power 5 into 6 plus, so minor of 7 equal to 6, but you see this is minus, so cofactor of 7 is minus 6. Clear? So this completes the calculation for minors and cofactors for the elements of second rows. Now I calculate them for third row. Cofactor of 0. Again I say, what is the factor when I expand this determinant by considering this element, that is cofactor. Ultimate value may be 0, because 0 into that quantity may be 0, but what is the factor associated with 0 when we expand this determinant by following our rule? So minus 1, number of row it belongs to 3, number of columns to it belongs to is 1. Omit them. 0 minus a plus 3. So this will be equal to minus 1 whole to the power 4. That means 1 and it is 3, so this is 3. Minor of 0 here is also 3. Now we proceed. Cofactor of 3. Number of row 3, number of column 2, omit them. Number of 3, number of column, omit them. Minus 10 plus 0 equal to minus 1 whole to the power 5 minus 10. It is minus, plus, so it is 10, but minor of 3 equal to within this bracket, omitting the sign in front of it as a multiplier. Minor of 3 is equal to minus 10. Last element in front of us is minus 5. Number of row it belongs to 3, number of column it belongs to is also 3. Omit them. 2 minus 0 equal to minus 1 whole to the power 6 into 2. Minor of minus 5 equal to 2. Here, since this is plus, so this is also 2. Whatever may be. But we obtain the minors and cofactors of any determinant in this way. Now we take a determinant, find its cofactors and we see some properties of cofactors of a determinant. Property number 1. Property number 1 is that the algebraic sum of products of the elements of any row, bracketed or column with the cofactors of corresponding elements. The algebraic sum of products of the elements of any row or column with the cofactors of corresponding elements of the same row or column is the value of the determinant itself. The algebraic sum of products of the elements of any row or column with the cofactors of corresponding elements of the same row or column is the value of the determinant itself. This is the property number 1 related with cofactors of a determinant. I explain it very simply. What I say, that is what says this statement of property number 1. Let delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. The property says that let you consider the elements of first row. So we take this element, and this element. Then we obtain its cofactor, and its cofactor. We multiply them respectively and obtain their sum. That means A11, A11. Because A11 is the cofactor of A11 plus A12, A12. This is called algebraic sum plus A13, A13. It is very simply, I take to explain it, to make it easy. So, the elements of any row, you may also consider a column. the elements of any row or column and cofactors of those elements when we multiplied respectively and added together like this. One may consider the elements of second row, then he or she get A21 plus A22 plus A23 or one may consider the elements of third row and cofactors of corresponding elements of that row and consider the product like this and algebraic sum to get A31 plus A32 plus A33 Here we consider only the elements of rows. But if you also consider the elements of first column, then you have to take A11 plus A21 plus A31. If you consider elements of second column, you have to take A12. The second A is capital A. That is the cofactor of this. A22, A32. A13, A23, A33. You see that all these are equal. And what will be this value of these expressions? Value of these expressions will be the expanded form of this determinant. The expanded form of this determinant. So here we explain it by considering the elements of rows only. Later I will discuss the considering the elements of columns also. Now I see what happens. Now you expand this. A11, A22, A23, A33 minus A23, A32 minus A12, A21, A33 minus A12, A21, A33 minus A23, A31 plus A13, omit A21, A32 minus A22, A31. This is the expanded form of this determinant. Here I merge this with the terms of cofactors. You see, this is A12 A12, we see the cofactor of A12 again. A12 equal to -1 whole to the power 1 plus 2 into omit this, A21, A33, A21, A33 minus A23, A31. Okay, so this is A2 and clearly this is minus. You see minus of this quantity A21, A33 minus A23, A31. So minus of this quantity is the cofactor of A12. Clear? So you write in the middle term A12, A12 plus what will be our A13 is equal to minus 1 whole to the power A1 plus 3 omit this A21, A32 minus A22, A31 and this is plus minus 1 whole to the power 4. So A13 is this A13 plus of, you see, A21, A32 minus A22, A31 is capital A3 and this is plus. So plus A13, A13. One term left. I now calculate it also. 1, 1, A11, A22, A33 minus A23, A32 you see this is plus, so A11 is this, you see plus this is nothing but capital A11 and so you may write it A11. Clear? So this expression is the value of the determinant. In this way you can calculate all the cofactors, multiply them with their corresponding elements, add them and you verify it with the expanded form of delta and you will see that the statement of property for the cofactors of a determinant 1 is verified easily. Now it is valid because in the bracket we write or colors. So you may consider the elements of first column, and you will see after expansion that this will be equal to A11 plus A21, A21 plus A31, A31. Clear? All the rest part left for you for your practice. You do them. If you face any problem, write in my comment box and I will explain details later in my next video. We verify this with some numerical problem. Take an example. Say, let delta equal to 3, 0, 2, 5, 7, 1, 0, minus 3, 4, 7. At first you expand it and find its value. 3, 28 plus 3 minus 0, whatever may be, plus 2 minus 15 minus 0. 31, so it will be 93 minus 30 to get 63. To write the value here, 63. Now let we consider the elements of first row. Let we consider the elements of first row. Cofactor of three, cofactor of 0, cofactor of 2. Cofactor of 3 minus 1 whole to the power 1 plus 1, 28 plus 3 equal to plus, so this is 31. Cofactor of 0, 20 minus 1 whole to the power 1 plus 2, 1 plus 2, 20 minus 0 equal to, this is minus because it is 3, so it is minus 20. Cofactor of 2 minus 1 whole to the power 1 plus 3, 1, 3 minus 15 minus 0. This is plus because it is 4 and it is minus 15. Now, we multiply these cofactors with the corresponding elements of first row and add them to see what happens. Now, 3 into cofactor of 3 plus 0 into cofactor of 0 plus 2 into cofactor of 2 equal to 3 into, what is cofactor of 3? 31. Plus 0 into whatever may be, this is 0. Plus 2 into cofactor of 2 is minus 15. Okay? And this is equal to 91, that is 93 minus 30 equal to 63. You see, the actual value was 63. Therefore, this is verified with some simple example. I have taken a very simple example to verify that property explained just earlier. That was some alphabetic format. There was no numeric form. Here we take numerical problem to establish, to verify, to justify the statement numerically. And easily you see that the statement 1 as a property of cofactors of a determinant is verified. Think the video you like it well. If there is any problem, please write down in my comment box and I will explain you later more details. Thank you all. Do the sums. Proceed. I will proceed in my next video.